Okay, I'm going to talk about unit conversions, and basically we've got to start with units. What are units? It's what we measure things in. And in physics, we don't talk about inches so much, we don't talk about pounds, we don't talk about things like that. We really deal with the KMS system, kilogram, meter, and second. Okay, and almost all of our other units are built up from that. So for force, it would be kilogram, meter, per second squared, which we call Newton. So they're all based on these three. You've got to be really solid at getting to these, what I call happy units, to what I like to think of as the units that we, I need more room up top, don't I? Yes, I do. Okay, so I'm up here. Hi, we're gonna, let's make sure there's room on that side. I don't care about that side. There we go, how's that? Okay. Good. Hi, we're going to start here outside because just for variety, even if it's almost 100 degrees, I guess 96 degrees today. But we want to talk about units and conversions. And we start in physics, we measure quantities with units. Number is almost meaningless without a unit. And the units that we like in physics are KMS, kilogram, meter, and second. Notice that it's not gram. Kilogram is the basic unit that we use for mass. It's abbreviated kg. Meter, length. Second, time. So we don't talk about inches, we don't talk about pounds, we talk about kilograms, meters, and seconds. Other units can be built up from that, what we call compound units. So for example, for force is in kilogram meters per second squared, which is ugly sounding, so we call that a Newton. So we measure newtons. Force is in newtons. And there are other compound units like meters per second for velocity. I'll just write it meters per second. I should be writing it over there. Meters per second squared for acceleration. Kilogram meters per second for momentum. All these things are based on these three, okay? So we need to be good at that. Got to be watching out for that. Kilogram, you'd think it would be gram, but it's kilogram. A kilogram of mass is something, weighs like a hardback book. It has the same mass, and we'll talk about the difference between mass and weight in the next unit. We want to be able to get everything into the units, what I call happy units, the physics units, the KMS-based units, because when we put them into equations, then we don't have to worry about carrying through all the units. If everything is in these KMS-based units, then all the results of the equations will be in those units. So it makes it a little easier to travel more quickly. Okay, now let's talk about conversions and how we do conversions. If I said it took me 4 minutes to make a video yesterday, you'd go pretty quickly. 4 times 60, okay, that's 240 seconds. You can do that in your head. Most conversions that we do are, though, they're not going to be nice round numbers. They're not going to be, we're going to have 3.6 times 10 to the third meters, and we've got to convert that to centimeters or something like that. It's not going to be as easy to do, so we need a process. The process that I use is like I think a lot of chemistry teachers do for unit conversion, which is the T-chart. T-chart, I'll just write that down, T-chart. And what that means is that we figure out what we're starting with, our base amount. And then we write over here our goal. We want to have it in seconds. This has to be the same thing as this, okay? They have to be physically equivalent. We're not trying to change the total measurement. We're just trying to change the name and the number. but they'll end up being the same thing. So you always want to check at the end, does this look like it's the same as this? So the way we do it with a T-chart is we draw a nice horizontal line, and I write an equal sign there. And then we put a vertical line, that's why they call it a T-chart. And then we do our conversions. To do our conversions, all we're doing is changing the name. Well, if I want to take this and not change the amount, I want to multiply it by a fancy version of 1. Okay, if I multiply this by 1, I'll have the same amount at the end. But since I want to change the name, what I mean by a fancy version of 1 is this conversion factor. And the conversion factor is the top and the bottom of this fraction that I'm going to multiply by is going to be equal to 1. Well, if the top and bottom are the same, it ends up being 1. I said that wrong before, but let's stick with me. I want to divide by minutes, because I can actually take that and say, okay, that's going to cancel out. And I want to multiply by seconds. So these units will cancel. This will be the unit that's left. But 1 second is not equal to 1 minute. This is not a fancy version of 1. So I have to say how many of these equal how many of these. And I happen to know that 1 minute is equal to 60 seconds. So all I've done is I've taken my base amount, multiplied it by a factor that ends up being 1. 60 seconds is equal to 1 minute. Numerator equals denominator, that's 1. So then when I multiply this out, I get 4 times 60 divided by 1, that's 240. And I get minutes times seconds divided by minutes, the minutes cancel. So I end up with 240 seconds. So all of this mathematically, all multiply the numerator divided by the denominator, I got that. And see, does it make sense? 240 seconds, that's a pretty long time. 4 minutes, that's a pretty long time. That seems reasonable. And what this helps with is, suppose I screwed something up here. I had 1 and 60. Then I'd have 4 divided by 60. I'm not really sure what that is. I don't know, 0.12, something like that. If I have 0.12 seconds is the same as 4 minutes, I'd know something's wrong. So you always want to come at the end and say, does this make sense? Okay? Now let's do a harder one. Sometimes you can do it in one step. Sometimes you're really familiar with all the measurements. Let's try a different one. I happen to know that 1 inch is equal to 2.54 centimeters. And I happen to know that 1 meter is equal to 100 centimeters. These are facts that I need to do conversions. And what I'm going to do is I'm going to say 3 inches is how many meters? So 3 inches equals how many meters? And I'm going to set up my T-chart. Remember what I do? This is my base unit. This has to be the same thing as this, the same physical amount. 3 inches is about that long. So if I end up with 1,000 meters, I know I'm wrong. Okay, so let's come back here. I need to multiply it by that fancy version of 1, that conversion factor. I want to get rid of inches. I'm going to put it on the bottom. It doesn't always work that way. We're going to have some compound units, I'll show you in a second, with some, if it were inches per second, I'd want to multiply by seconds to cancel out the seconds. You've got to be always thinking about what will make them cancel out. Inches, I would like to convert inches to meters, but I don't know that adjustment. So I'm just going to use this. I happen to know this fact. Okay, I'm going to convert inches to centimeters. What I like to do is go through and say, try to develop a map. Before I even fill in any numbers here, I want to actually make sure I can get there. Okay, so now I've got inches divided by inches. I've got centimeters. I want to divide by centimeters because I don't want meters. Centimeters. I want meters. And I happen to know how many meters equals how many centimeters. As long as I can find some equation, this, some number times this equals some number times that unit, then I'm okay. Now let me go back and you can see the inches are going to cancel out. The centimeters are going to cancel out. I'll be left with meters, so it's successful. Now let's look at this, 2.54 centimeters, and I'm realizing right now is really kind of stupid to do one that I can't do in my head because I don't have a calculator out here, but I'll show you how it goes. Okay, 2.54 centimeters equals 1 inch. Every one of these is a fancy version of 1. The top has to be the same. Here's 2.54 centimeters. here's 1 inch. They're the same thing, okay? If I stopped there, inches would cancel. 3 times 2.54 would be how many centimeters there are in 3 inches. Okay? Notice I didn't even have to look at the 3 when I was setting this up. Now I'll come over here. I cancel out centimeters, bring in meters. How many meters equals how many centimeters? There's actually 2 ways to write this. There's this way, 1 meter equals 100 centimeters. I could have written 10 to the negative 2 meters equals 1 centimeter. A small number of meters equals 1 centimeter. The reason I do that sometimes is you're going to see I'm going to give you these metric conversions, and sometimes they're written like this. You can always write centimeters to meters like that. 1 meter, boom. 100 centimeters, boom. Same thing. This divided by this is 1, so we're not changing that base value. Now we go through 3 times 2.546, 7.62 times 1 divided by 100, 0.62.0762 meters. I'm sorry, inches divided by inches, centimeters divided by centimeters, meters is what left. 0.0762 meters. I don't know, 1/10 of a meter would be about somewhere in here. 3 inches. Okay, that makes sense to me. So that's how we do it. We set this up, multiply it by these conversion factors, get our result, and then check. Always, always, always check. Last thing I'm going to say on the conversions. Sometimes you've got something like this. 3, let's just say it's going 3 meters per, or let me get a better one, let's say 1,200 meters per minute. That would be a velocity or a speed, okay? If I want to get it into my happy units though, I want it in meters per second. I don't want meters, I want seconds. To do that, 1,200 meters per minute, I make my T-chart. Want to multiply it by a fancy version of 1. Meters is okay, I don't want to change that. So I don't want meters on the bottom here. Don't have to do anything with the meters. Minutes I want to get rid of. I don't like minutes, I like seconds. To cancel out something in the denominator, you multiply it by something in the numerator. So I want to convert it to minutes, I want to convert it to seconds. That will cancel out the minutes, and I'll end up with meters per second. Perfect, just what I wanted. Well, let me think, how many 1 minute is equal to 60 seconds. Therefore, 1,200 times 1 divided by 60 is 20 meters times minutes divided by minutes divided by seconds, meters per second. So always, always, always look at the beginning and the end. 1,200 meters per minute, that's less than a mile, a little less than a mile. If you're going 20 meters every second, that's like the width of my backyard maybe. If you do that every second for 60 seconds, yeah, you're probably going to travel about a mile. So that makes sense to me. So always try to be thinking about getting things back to our happy units, our KMS-based units, and always think about how to do this formally.